Okay, everybody, let's see what's going on here. Dot product, yes. And let's see if we can change the title. You know, I want to change it. All right, you guys okay with this? Here's a dot product, and what can we do? The dot product is really multiplication between two vectors. So we can multiply two vectors together, all right? So that's what you guys want to learn and know as well. Dot product, you know, when you think about a dot, what do you guys think about? This is a dot. Now, we're really looking at this idea. You take two vectors and you multiply them together. So what is this dot product? U with V. You guys know A1 times A2 plus B1 times B2. So we're going to find dot products. Now, this is called vector multiplication, okay? So if I go down here in my worksheet, let's do something here. Let's give you guys some scratch, okay? So let's do some examples of dot products. So I'm going to call this here, well, let's go back to our vector scratch. Dot product. Here's vector 2, 3. Okay, and let's say here's vector negative 1, 4. So if we want the dot product, this is vector multiplication. That's defined this way. Let's go back to our orange and green, okay? You see this orange? You see this green, okay? What you do is you multiply the horizontal components together, and you add it with the product of the vertical components together. So this is negative 2 plus what? 12, okay? This is how you define the dot product. This is vector multiplication. And then you can say, oh, that's positive 10. So, ladies and gentlemen, this is what we call the what? This is our dot product. And there it is. This is a form of vector multiplication, okay? This is the definition of dot product that I have in that worksheet for you guys, okay? So I'll put this even in the chat. So if you said, can I have that? Sure. Okay, you guys okay with that? The dot product? So let's have you guys try some dot products, right? So let's go through this because this is a very easy thing to do and it does have some meaning, okay? So let me do this here again so you guys are aware. Here's A1, B1. Vector V is going to be what? A2, B2. U dot V becomes what? A1, A2 plus B1, B2. So I'm going to share this with colors here. And go through the dot product. So if I ask you guys here now, let me do something here. All right. I'm going to get the dot product here for these vectors here. So I'm going to try to get some do the first part. Vector scratch. Vector scratch. Where are you, vector scratch? Hey, vector scratch. Okay, oh, there we go. Here's our vector scratch. Okay. Hey, where'd you go, vector scratch? Oh, there it is. All right. So here's what I want you guys to do. I'm going to give you guys some time to get the what? Dot product here. Okay. So get the dot product of these vectors. And I'll give you guys some time, okay? And it's fun. This is multiplying vectors together. Let's see if you guys can get these answers, okay? And of course, is that going to be on your final? Yeah, you're going to have to do some dot products. So ladies and gentlemen, try that out. Let's get out our clock. And let's see what you guys can do here, okay? Okay, should we try the dot products? Let's take a look, ladies and gentlemen. What do you have to do for question 1, right? You take 2 and you multiply it by 1, is that right? Then you add it with -1 plus 3. So in the dot product here, u dot v, this is question 1, it'll be 2 times 1 plus -1 times 3. 2 plus -3. What's 2 plus -3? It's -1. You guys know what you got? The dot what? Product. Okay? So you multiply 2 vectors together. All right. Let's try question number 2. U dot V, let's use that as a roadmap. What's it going to be? 0 times 1, is that true? Plus what? 4 times -1. So what do you get? Isn't this going to be what? 0 plus what? -4. And what's 0 plus -4? -4. There you go. Easy peasy lemon squeezy. What do you think? It's pretty simple. This is called the dot product. Okay, so number 3 now. You're going to take -5 times 6 plus 1 times -6. Okay. Negative what? 30 plus -6 will give you what? -36. You guys get that answer? You guys okay with that? Okay, now the next one's going to be what? What's the next dot product? 0 times -2, right, plus 5 times 3. Let's see. 0 times -2 plus 5 times 3. And what does that equal? 0 plus 15, which equals what? 15. Okay, and that's number 4. Number 5. This is going to be what? 3 times 4, -4, -1. Oop, wrong color. -4 times -1. What's 12 plus 4? Is that 16? You guys okay with that? All right. Dot product, ladies and gentlemen. Now, this is a form of multiplication. So what I have also here for you guys with the dot product is various properties here, right? So what I'm saying here, if you take the dot product of two vectors, if you change the order, u times v is the same as v times u. Right? It's kind of like multiplying two numbers together. 5 times 3 is 3 times 5. It's commutative. And then you have these kind of properties where alpha is a scalar value. That just means number. And, you know, you can actually do and show that if you multiply alpha times u and then multiply it times that v, you know, it's the same as, I should say, just changing the order is fine. This last property is a form of the distributive property. So this is like saying you have the distributive property, okay? So it looks like that property. Now, I think in some ways, though, this property, number 4, is a very useful property. Okay? So number 4, we're going to talk about that one, all right? So what does that mean on our scratch? Number 4, that's kind of special. So in our scratch, I'm going to write down that property here. You know, this is kind of a good property to know. Here's a fact. That if I take the dot product with u, if I multiply a vector by itself, right? So that will be a1 times a1 plus b1 times b1, which really becomes a1 squared plus what? b1 squared. Because remember, what in the world is u to begin with? U is this vector. Okay, so you're multiplying u with itself is what they're saying here. Okay, so let's remember this. This is kind of what we're going with here. What happens when you multiply a vector with itself? Well, it's really a1 squared plus b1 squared, okay? Now, I want you to also note, if I say to you, what is the length? Let's note this. What is the length of a vector? Let's note. So that would be a1 squared plus b1 squared. Isn't that the magnitude of the vector? Is that right? You guys with me on that? And if I square this using a little bit of algebra, we get the length of u squared removes that what? It removes the parentheses. Okay? So let's use our logic. Let's remember this. This is exactly the same here. Here's a1 and here's what? Here's b1 and here's the squared. So what that property is saying is, this is the same as taking the length, that value of the vector, and just squaring it. So what we're showing here is that u dotted with u is equal to the length of that vector u to the second power. This is kind of like a proof of that. Yeah, it's related to, it is the Pythagorean theorem. That's right. This is like that c squared. You're right. Exactly. This is like that c squared, because c is the length of the vector, right? So you're right. This is kind of like Pythagorean theorem. Absolutely. Okay. All right. You guys okay with this one? So I want to share with you guys that property with the dot product is a pretty big one. And after that, let's look at this picture here. Okay. There's a geometric version of the dot product. And you say, what do you mean a geometric version? Well, what they're going to say is if you're taking two vectors, u and v, like we've been doing here, okay, and you want theta to be the smaller angle between them. So here's your theta angle. It's a smaller angle between these vectors, where theta is going to be between 0 and pi. The dot product, ladies and gentlemen, can be described also this way. You say, what do you mean? We can take this dot product, u and v, if we take the length of u and the length of v and the cosine of the angle between them, that is actually exactly the same, ladies and gentlemen, as the dot product definition I gave you. Meaning u dotted with v is the same as that a1 squared, oops, sorry, not a1 squared, a1 a2 plus what? b1 b2. All right, you guys okay with that one? That's a geometric version of your dot product. Okay. And I guess we can prove that. Yeah, we might be able to look at that and prove that, but we're going to end right there because we're out of time. All right, so I want you guys to know you do have a geometric version. Maybe I can show you an example. Well, we'll do it tomorrow. So show up tomorrow, ladies and gentlemen. I hope you guys enjoyed the end of the vector applications. So we'll see you guys tomorrow. Take care and stay safe. Sorry about that. Looks like the audio was muted. So let me go back and talk a little bit about this here. Okay? We have the dot product that was defined for us yesterday. It is the multiplication of vectors. And we have the multiplication properties here. Now we have a geometric version of the dot product. And so what I'm about to do is prove the geometric version of the dot product, but that theta is going to be the shortest angle between the two vectors. So I'm going to start here by sharing with you guys the freeform version of vector addition. So here's going to be the vector sum of u plus v. But I'm going to say minus u plus v. You got now the vector difference. So if I said to you, minus v is in red, we're going to have vector u plus that negative vector v is going to be really a vector difference. So you might say, well, where is this vector? Well, here's u, here's minus v, and here is the sum of those vectors here. If I can draw it that way. What we also have to move that vector along, this is a parallelogram. If I can draw it in there here, let me see if I can change the dimensions here. Let's try it again. Okay, that might be okay. But it might even be here. Something to just write this way here if I can. And so here's going to be, let me get rid of this since we can move those vectors freehand. You're looking at that vector u minus v now. Well, there's minus v. I apologize. Sorry. This is where vector minus v is. And so what I can do now is if I can move that, I'm going to share with you let's get that here. Okay. Okay, so now we have vector u. We have this vector minus v. So if I wanted to add that vector, u minus v here, just moving this freehand, I'm going to get this purple vector. This will be vector u minus vector v. And going back to that parallelogram, let's try that again. If I can draw a parallelogram. I believe that vector should be right here. It's the same vector difference here. Okay, let's get rid of all the distraction. I apologize to you guys here. Okay, so you got your vector difference there, and this is called the parallelogram law. So what I like to do here is this. Let's kind of use here law of cosines here. Where the length down here, this is going to be the length of vector u. This is the length of vector v, and this will be the length of vector u minus b. Okay, so we're going to use here the law of cosines, and notice theta is the angle between the vectors u and v here now. All right, so let's go to the scratch here. Now that we know what's going on, I think it's our vector scratch. And here's what I'm going to start with this proof here, okay? We've seen here that square vector from yesterday, right? If I take this, this is going to be, well, by law of cosines. Just by law of cosines. Okay, so here's our law of cosines. And this is what we're getting at. We also know from yesterday that this is going to be the dot product of, this vector by itself. This is that property that we looked at yesterday. So this is thought of as a single vector, that difference, dotted with itself. And we could distribute, okay? Essentially, we can use FOIL. So this is u dotted with u minus u dotted with v minus v dotted with u and plus v dotted with v. So essentially what you're doing here is FOIL. Okay, we'll even write that down by FOIL. And u dotted with u is that length of u squared. This will be minus 2 u dot v plus the length of v what squared. Okay? And so we're going to use that logic that we had here. So if I do here, this is going to be maybe everything in blue here. This portion and this portion, this is equivalent to what you see here, which is equivalent to what you see here. So what that means now is the top in brown, I'm just going to copy that, is equivalent to the gray. Okay? Okay, so these equations are now equivalent. It's that Jennifer Lopez's J-Lo logic, right? J-Lo is Jennifer Lopez. Okay. You put it down here. Okay. So now, ladies and gentlemen, you're going to cancel. This portion cancels. This portion cancels. And notice this. Negative 2 cancels. So what you are left with on top is the length of u times the length of v cosine theta will be equal to u dot v. Or u dot v is that length of u, length of v, cosine theta. The angle between them. Okay. So that's the important fact that I have in that worksheet for you. However, you might say, well, how do we actually use this? I'm going to say to you guys, how can we use this? Well, we can solve for cosine theta. Cosine theta is going to be u dot v over the length of u times the length of v. And that's how we can use this. Okay, so you might say, well, what is that good for? This is going to tell us the angle between two vectors. Okay, so we have the angle between two vectors. And that's the deal, ladies and gentlemen. We can find any angle between two vectors, and that's in our vector scratch. However, I did put that in the notes under dot product. There you guys go. All right. So remember this from yesterday. I said to you guys, can you find the dot products of these vectors? Didn't we do that yesterday? And now we're going to ask you guys, can you find the what? The angle between two vectors, the shortest angle, using that formula. Okay, so I think we still have that in our vector scratch. Okay? So let's look at the first one here so you guys can get a good understanding of how to find the angle between two vectors. So if I see the first situation here, number one, you have vector u is 2, -1. Vector v is 1, 3. Okay? So we're going to use cosine theta being the dot product of u and v divided by the length of u, length of v. So we can write that down. Cosine theta is u dotted with v divided by the length of u times the length of v. So that now we can write that down. 2, -1 dotted with 1, 3 divided by, how do you get the length of u? You guys know? That's the square root of 2 squared plus -1 squared, the square root of 1 squared plus 3 squared. So it's 2 times 1 plus -1 times 3, the square root of 4 plus 1, square root of 1 plus 9. Should be 2 minus 3, the square root of 5 times the square root of 10. And that's going to be -1 over the square root of what? 50. So here's your cosine of theta. Now, theta is going to be inverse cosine -1 square root of 50, ladies and gentlemen. And that's going to give you the angle. So when you go through this process, you're going to need to use your TI now. You get out your calculator. And let's see what we get here. Okay, let's double check. What's our mode? Degrees. Okay. Let's see if we can scroll out so you guys can see this. Second inverse cosine -1 divided by the square root of 50. And what do you guys get? Let's go to the nearest degree. This is going to be what? This is 98 degrees. Is that right? It's 98 degrees. So if I wanted to go back to these vectors, by the way, if I said to you guys, let's take a look at this here. Let's graph those vectors, just so you guys can see the point. Do you guys know how to graph those vectors? How do we graph this? Right? We're going to graph vectors by entering following picture. Okay, so 2, we're going to go to 2, -1, which is to the right 2, down 1. However, we need the initial point being the origin. Here's our vector v, or u, sorry. Vector v is 1, 1, 2, 3. Okay? So what you guys found is that this is a 98-degree angle. Is that right? There it is, vector u, vector v. It's a 98-degree angle. And so that's the angle between your two vectors. Okay, you guys okay with that? And that's what you're really looking for. The angle between two vectors. All right, let's take a look at the second one here, okay? So for number 2, do you guys want to close that door? So remember, we need to take the dot product. Is that right? Divide by the length of u times the length of v. So you can say 0 times 1 plus 4 times negative 1 over the square root of 0 squared plus 4 squared times the square root of 1 squared plus a negative 1 squared. Negative 4 over 0 plus 16, 1 plus 1, negative 4, square root of 16, square root of 2. Negative 4 over 4 times the square root of 2. So this would be negative 1 over the square root of 2. So this is our cosine theta, okay? And what that means then will be theta will be that inverse cosine. Is that right? Negative 1 over the square root of 2? Yeah. All right, so let's go to the TI. And you say second inverse cosine, negative 1 divided by square root of 2. And what's this angle? That's 135 what? Degrees. Is that true? Okay, well, let's take a look at this. We want to look at the picture here. Let's look at the graph of these vectors here, okay? Let's enter this. We got to plot 0, 4. That looks like it's straight up here, 4 units, okay? So this is the location of 0, 4. That means this is the vector. Go to the right 1 and down 1. And there's your vector, 1, negative 1. But the angle between them, they said, is what? 135. So let's think about this. Is that the shortest angle between the two vectors? 135 degrees. What are they actually saying? Is this angle, that's the theta we're looking for. That's the shortest angle. Is that true? Does that look like that can be 100 and what? I don't know. Is that, what angle is that? Is that 135 degrees? What do you guys think? Looks like it's 135 to me. Is that right? So there you go. So that's the angle, the angle between the two vectors. And that's what you're looking for. Can you find the angle between two vectors? So ladies and gentlemen, this is the process. Okay? Anybody have any questions on that? Getting angles between two vectors. How about if I ask you guys, can you do 3 and 4? Can you find the angles between vectors 3 and 4? Let's have you guys do these yourself. 3 and 4. We'll give you guys some time. Let's see, did you guys get anything here? So I'm going to copy this down here. Okay, so let me try to do this here. Copy number 3. Vector u is -5, 1. And vector v is what? 6, -6. Trying to find the angle between these two vectors. Okay, it took everything. Can I? All right, well, okay. Okay, let's try to find this out. So cosine theta u dotted v over length of u, length of v. -5 times 6 plus 1 times what? -6. Over the length of -5 squared plus 6 squared. Square root of 6 squared plus -6 squared. Okay, and we get what? -30 plus -6. Square root of 25 plus 36. Square root of 36 plus what? 36. So -36 over square root of, what's 25 plus 36? Isn't that going to be what? 61, and then this is 72, it looks like. Is that right? So if you guys like, you know what you can do? Just take inverse cosine of all of this. You're going to put it in your calculator anyway. And let's see what we end up with. Okay, so let's try this out. So let's do a double parentheses. I mean, I'm going to put a 36 for the dot product. Close that. Divided by parentheses second. That's the square root of 61. Second square root of what? 72. What's the angle going to be approximately? 100 and what? 123 degrees. So, ladies and gentlemen, that's 123 degrees. If you wanted to plot negative 5, 1, just to kind of illustrate it, here's negative 5, 1, and the other vector is going to be what? 6, negative 6. So what's the shortest angle between these two vectors, right? That's theta. That's the shortest angle. So does that look like that's 123 degrees, ladies and gentlemen? I think so. Is that right? Okay, that's number 3. Let's see number 4. What was number 4? 0, 5, negative 2, 3. So number 4, 0, 5, negative 2, 3. So let's find the angle between these vectors. So you have u dotted v, length of u, length of v. So 0 times negative 2 plus 5 times 3, square root of 15 over square root of 25, the square root of what? 4 plus 9? Here's going to be 15 over 5, square root of 13. 3 over the square root of 13. Okay, let's find the angle between them. Second cosine, 3 divided by second square root 13. What is this going to be? $34 degrees? Okay, you guys okay with that? So if we had to graph these vectors, number 4, 0, 5, negative 2, 3, let's bring this graph in. So 0, 5 would be right up here. 1, let's see. And then negative 2, 3. 1, 2, 1, 2, 3. So if we kind of look at this, this is supposed to be 34 degrees right in here. And there you go, ladies and gentlemen, 34 degrees here. So that's the deal. This is how this works. Now, what I'm going to say with you guys here, if we go back to the notes, go, where are you, vectors? Dot product, okay. Here's another extremely important definition, okay? Right? We say the two vectors u and v are orthogonal. Do you guys know what orthogonal means? Huh? They're perpendicular to one another. Orthogonal is a fancy way for being what? Perpendicular. And that means the angle between the two vectors is really what? 90 degrees. So when you have a 90-degree angle between vectors, what do we say? They are what? They're perpendicular. Or they are what? Orthogonal. Okay, perpendicular vectors, they're orthogonal. So here's a very, very simple fact here. If that angle is 90 degrees, let me go back here to this formula here, right? Notice the dot product formula. The geometric version when this angle is 90 degrees, pi over 2. You guys know anything about cosine? What's cosine of 90 degrees? Isn't that what? Isn't that 0? If you let theta be pi over 2, is that 0? Cosine, yeah, so what that means is your dot product is going to be what then? 0. So if the dot product is 0, then u is perpendicular to v. If the dot product is 0, you know, you have orthogonal vectors. So, as an example here, they say determine whether the two vectors are orthogonal. So for number 6, u dotted v 6 times negative 2 plus 4 times 3. Negative 12 plus what? Ooh, what's negative 12 plus 4 times 3 is 12. Is that true? What's the dot product for number 6? It's 0. What does that mean about these two vectors? They are what? They are orthogonal. So for number 6, they're orthogonal. And if I were to bring in, maybe I can bring in a graph here. I don't know if I can fit that in, but 6, 4, negative 2, 3. Let's go to our scratch. That's not the scratch. Where are you, vector scratch? 6, 4, negative 2, 3. These vectors are what? They're orthogonal. That angle's 90 degrees. Okay, you guys okay with that? That's the idea behind it. So the dot product is very, very important, that multiplication, to tell you if you have orthogonal vectors. Let's look at number 7 now. Let's see, the dot product here for number 7 will be 0 times 1 plus 1 times 0. And what do you guys get? 0 plus 0, is this going to be 0? Yes. And let me erase the scratch work over here. So for number 7, what do we know about these vectors? They are what? Orthogonal. You say 0, negative 1, 1, 0. 0, negative 1, 1, 0. Sure enough, what do you know? They're what? Orthogonal. Okay, do you guys see that there? See the vectors? All right. Easy peasy. You guys like the dot product? Let's see about number 8, or the orthogonal now. U dot V will be 2 times 3 plus 7 times what? Negative 4. Doesn't that give you what? 6 minus 28. What's 6 minus 28? Negative 22. That is not 0, is it? So when it's not 0, we say the vector is not what? Orthogonal. How do we say that? You cross that. You cross it out. So that means here these vectors are not what? Orthogonal. That's some geometry notation. Mm-hmm.
So what we'd be doing was to find theta. This is just these things.
Hmm?
So the one that we read, the thing we were reading before, that was just to find theta. This one's looking for.
We're trying to see if they're orthogonal. And you say, how do we know if they're orthogonal? Perpendicular, right? If the dot product is what? 0. Three minus 4 is what? Negative 1. What does that mean? These are not what? Orthogonal. Number 10. This is negative 12. Is that right? Negative 6 plus negative 6. So what do you guys know about number 10? The vectors are not what? Not orthogonal. So you're using this dot product has to be 0. All right, you guys okay with that? All right, now let me just leave with you guys with this last definition here today. Definition of what we call the component of U along V. Now, here's two vectors. U and V, graphically speaking. If I said to you, the component of U along V, that component of U along V, think of this as a shadow. First of all, it's a scalar value. There's your shadow. It's a scalar. So you think of it as a shadow. So you need the length of U times cosine of the angle between the two vectors. That's a scalar. That's the definition of what we call the component of U along vector V. The component of U along V. Length of U cosine theta. And this is when the angle, by the way, is bigger than 180. Then that shadow here, we're going to find will be a negative shadow. But it's a shadow, the component of U along V will be negative, but that shadow is going to be, you know, it's the same idea. We're looking for the shadow, that length of the shadow, right? So you really think of it that way. You're looking for the length of the shadow. Okay, so let me put this together here, right? So if they said to you, we already know that the geometric definition this is the geometric definition of the dot product. The shadow of what we're talking about, length of U, cosine theta, this definition up here, we can solve. What that means is length of U cosine theta is U dot V over the length of V. So if you're going to look for the component of U along V, this is what you look for. And that's what I put down here. Okay, so that's the formula that you guys can very quickly use to find the component of U along V. Okay, just take the dot product with U and V and then divide by the length of what? V. So for number 11, the component of U along V, you're going to say 4 times 3 plus 6 times negative 2 divided by that length of V. Square root. Three squared plus negative 2 squared. So this will be 12 minus 12. And that's the square root of what? 9 plus 4, and you say, Mr. Judge, that's the square root of 13. You mean that's 0? Oh, I guess so, because why? The vectors are what? Orthogonal. So when you have orthogonal vectors, there will be no what? No shadow here. Okay, there will be no shadow when the vectors are orthogonal. See this picture? There'll be a shadow. Here, there'll be a shadow here. The shadow of vector U along V. Let's see if number 12 has a shadow. Is that right? Negative 3 times negative 1 plus 5 times 1 divided by square root of 1 squared, 1 squared. 3 plus 5 over the square root of 2. So that would be 8 over the square root of 2. Now we can rationalize the denominator. And that gives you 4 what? Square root of 2. So this is the shadow, the component of u along V. That's the scalar value. That's the length of the shadow. All right, so this is going to be a good information for us for tomorrow. 13. 6 times 1, okay, plus 4 times 1, the length of V. Square root of 1 squared plus 1 squared. 6 plus 4, square root of 2, 10 square root of 2. That becomes 5 square root of 2, is that right? That's a component of u along V. This is the shadow. Okay, let's try number 14 here. Let's find the length of the shadow. 6 times 1. Oops, sorry, that's not 14. Negative 2 times 4. 3 times 0. Okay. It's really negative 8 plus 0, right? Let me get rid of this. And you get square root of 16. It's really negative 8 over 4, so the length of the shadow is negative 2. Okay. Let's try the length of the shadow. 0 times negative 1 plus 5 times negative 3 square root of V. Square root of negative 1 squared plus negative 3 what? Squared. Negative 15 over square root of 1 plus 9, or square root of 15 over the square root of 10. So when you rationalize the denominator, we'll get negative 15 square root of 10 over 10, or negative 3 square root of 10 over what? 2. There you go. Easy peasy. Lemon what? Squeezy. So ladies and gentlemen, we're ending the dot product. These are some interesting ideas behind the dot product. You can find the angle between vectors. You can find when they're perpendicular, and you can find the shadow of a vector, the length of the shadow. So we're going to apply these things tomorrow. So I'll see you guys when? Tomorrow. Tomorrow's what day? Thursday. Take care and stay safe.